Today we're going to talk about transforming polynomial functions. This is really a continuation of what we were doing before with the parent functions. If you notice, the vocabulary for today is going to be very similar to what we were talking about before. However, it's just a little bit different. So review the parent functions because the rules are basically the same. If we are inside talking with the x, then we're going to do the opposite. This one is going to move us 3 to the left. If we are outside talking to the y, then we'll do the same, moving up or down. This one's going to move us up 5. A negative reflects the graph. A fraction less than 1 gives us vertical compression, and a fraction greater than 1 gives us vertical stretch. If we come over here and write it in function notation, the basic rules are the same. It just looks weird because we have the function. So if I have f of x plus a number, that's going to be a vertical translation. If it is plus, it's going to go up, and if it's negative, it's going to go down. If you have a plus or a minus on the inside here, f of x plus or minus something is going to move left and right. Remember, we still have those rebellious numbers, so it'll go in the opposite direction. A whole number in front is going to stretch the whole graph, and a fraction less than 1 is going to compress the whole graph, and that's going to be a vertical. Now, if we put a fraction inside next to the x, then we're going to have a horizontal stretch or compression. And your reflections, if there's a negative outside the whole thing, what's going to happen when you rewrite it is you're actually going to distribute that negative through, and you're going to get a reflection across the x-axis. But if there's only a negative on the x, then it's going to reflect across the y-axis. All right, let's run through a few examples. The first one says g of x, which is our new function, is equal to the old function f of x, but there's a minus 3 on the inside and a negative 2 on the outside. So they are asking us to describe what the transformation is. Well, for this one, we're moving 3 to the right and 2 down. So look at the one on the right. We have a 2 in the front, and then a negative 3 and a negative 2. So we're going to have the same translation, but we're also going to have a vertical stretch of 2. The next one, g of x, is equal to f of negative x. Well, there's a negative on your x inside, so that means you're going to have a reflection. The reflection in which axis? The reflection in the y-axis. And the last one at the bottom, we have a negative in front of your function, so that's another reflection, and then the negative 3 on the outside. So you're going to reflect across the x-axis, and you're going to move 3 down. All right, let's look at some examples of how this actually looks. Now here in blue, we have f of x is equal to x cubed plus 4, and that's what they wrote right here in blue. Then they drew a new graph plus 3. So all they did is they took the original graph and moved it up 3 dots. So you still have the same x cubed graph. The only difference is we've taken it up 3. So the new function will be x cubed plus, and 4 plus 3 is 7. So if you notice, we went up a total of 7. Then down here it says f of x minus 5. So if the plus 3 on the outside moved us up 3, the negative 5 on the inside is going to move us to the right 5. So your new graph is going to simply shift that blue one to the right 5. And the new function will be x minus 5 cubed plus 4. We didn't change the vertical with this, we only changed the inside and it moved to the right 5. Similar to the last two, they give us an original function, x cubed minus 6, and then they tell us they're going to change it. Here they're going to take the x cubed minus 6 and move it down 2 more. That's going to give us x cubed minus 8. We move down 6 and we move down 2 more, so our g of x is equal to x cubed minus 8. Now they want us to graph it, and when we graph it, we go down 8 and put a dot, and then we graph the normal x cubed function. Next, they tell us f of x plus 3, so we're going to take that same original equation and move it. They want plus 3 on the inside, so you just put a plus 3 on the inside. X plus 3 cubed, still minus 6, but now they want us to move to the left 3. 1, 2, 3. Remember, it's rebellious numbers, so if it's a plus 3 on the inside, we move to the left 3. And then you graph a normal x cubed function. Should look something similar to that. And for completion's sake, we can go ahead and graph the original. That original x cubed minus 6 was right here and just looked like a normal x cubed function. Now they give you another x cubed function here, x cubed plus 5x squared minus 8x plus 1. It says write a function that performs each transformation. Now I'm not expecting you to know how to graph it. I did put the graph there on the right for you, but simply they want us to do the math side of things to see how it works. So it says reflect across the x-axis. Remember, reflection across the x-axis is going to be g of x is equal to negative on the outside f of x. Well, what that means is that you're going to have a negative and then your function, which then means you distribute. After you finish distributing the negative sign through, negative x cubed minus 5x squared plus 8x minus 1. We simply reversed all of the signs all the way down. Then they want you to reflect across the y-axis. Well, that's going to be g of x is equal to f of negative x. What this means is that you're going to put a negative sign inside the parentheses in front of each of the x's. So you have x cubed, negative x cubed. Don't forget the parentheses. And the 1 doesn't have an x, so it's just plus 1. Now you need to simplify that. Negative cubed, a negative times a negative times a negative is still negative, so we get negative x cubed. Negative squared is a positive, so that didn't change. Here I have negative 8 times negative x gives you a positive 8x, and the plus 1 didn't change. So that would be a reflection across the y-axis. Here they say write a function that transforms f of x equals 6x cubed minus 3 in each of the following ways. And then they say support your solution by using graphing calculator. What that means is you can come back later and graph both the new and the old and verify that it did what it said it was supposed to. Right now we're just going to work on it mathematically. So it says compress vertically by 1/3. Remember, vertical compression is going to be the fraction in front, and then they say 2 units to the right. So remember what that does is it tells you to put a negative 2 on the inside. 1/3 times the whole thing, and inside here we're going to have a minus 2. Now distribute. That's going to give me my new function of g of x is equal to 2 because 1/3 times 6 is 2. X minus 2, and I put the minus 2 in there because they told me to shift 2 to the right. And then a minus 1 at the end because 1/3 times negative 3 gives me a negative 1. The next one says to reflect across the y-axis and shift down 2. So we just learned that reflecting across the y-axis means it's going to be f of a negative x, and then the down 2 means you're going to have a minus 2 at the end. So it should look something like this. A negative cubed is still negative, and negative 2 and negative 3 gives me negative 5. All right, now that we're experts, we can go through these pretty quickly. They give us the function and then tell us to transform it in multiple ways. Compress vertically by a factor of 1/2 and move the y-intercept 2 units down. So for number 10, a vertical compression means you're going to have 1/2 on the outside. And 2 units down mean you're going to have a negative 2 at the end. And it's going to look something like this. Now the big one on this is don't forget your order of operations. The order of operations, so you have to multiply by the 1/2 first, and then you can subtract by the 2. So the answer for number 10 is 2x cubed minus 1. For number 11, reflect across the y-axis and compress horizontally by a factor of 1/2. half. So if we're moving across the y-axis, the negative is inside. And if we're doing a horizontal compression, then the 1/2 is also on the inside. It's going to look something along these lines. 1/2 cubed is 1/8, and then negative cubed is negative. Now, here's the trick. Think about when the problem has a parenthesis with an x and a minus or a plus on the inside. Don't we always do the opposite? Well, that's the weird thing about the horizontal compression. The horizontal compression is inside that parenthesis. A horizontal compression is basically the same as a vertical stretch. So if I want to lose those parentheses and combine what's inside with the 4, I'm actually going to be doing the opposite. So instead of multiplying 4 times 1/8, I'm going to multiply 4 times 8. The opposite of 1/8 is 8/1. And that's going to give me 32. And this is why, because I want to get rid of the fractions, so I take it out of the parentheses. Just like all the other rebellious numbers, it has to do the opposite. So that's going to give me negative 32x cubed minus 2. Because a horizontal compression is basically the same as a vertical stretch. So when I compressed it horizontally by a factor of 1/2, I actually stretched it by a factor of 8. And the last one says move 2 units to the right, 3 units down, and reflect across the x-axis. That's going to give me a negative on the outside, so remember we're going to have to distribute that through. X minus 2 is going to go inside the parentheses, and then negative 3 at the end. Don't forget your order of operations. First thing we're going to do is distribute the negative sign through, and then we can combine the 2 and the 3.